3 lesson 1 extra examples. This will be extra examples 7 through 10. Oddly enough, I'm going to start on 10, and the reason I'm starting on 10 is that way if I have extra time, I'm going to just use all of my time to do 9. So the difference quotient is given right here. Then we're going to take this function and use the difference quotient. In this says the function and then replace every x with x plus h minus the original function. So we come here, we're going to have 4 times x plus h plus 3 minus our function, which is the 4x plus 3. All of that then is going to be over h. I need to distribute and combine like terms. This is going to be 4x plus 4h plus 3 minus 4x plus 3 all over h. I'm going to combine like terms, and one of the things I noticed is that the 4x combines with a negative 4x, and those two things cancel out. So what I'm left with, and you know what, I've done this multiple times, and hopefully you haven't, because this is a common error, right? It's a subtracting the function, so it's really like distributing this negative to everything here. So this would be a negative 3. So now our 3's cancel out. I'm left with 4h over h. My h's can cancel out. I'm left with 4. Okay. Now I'm going to pop back and do the other examples. So example 7, find the domain of the function. Is this function a fraction? No. Is this function, or does this function have a radical? No. So therefore, it would be all real numbers. What is the domain of the function? Is this a fraction? Yes. So the denominator cannot equal 0. So I'm going to have x squared plus 1 equals 0. Subtract 1, x squared equals negative 1. Okay, and if you were to take the square root of that, or take this, you're granted this is a negative. So this one kind of takes some thought process, but technically if we just looked at this as 1, it would be x could not equal plus or minus 1. However, no matter what I put in here, because this is squared, so it doesn't matter if I put a positive or a negative, I'm still adding it, and this positive or the negative is going to remain a positive, and we're adding it to 1. So therefore, this one still is all real numbers. And the reason for that is because it doesn't matter if I put a negative or a positive here, this is going to be a positive plus 1. So even if I have a negative here and negative 1 squared is 1, 1 plus 1 is 1. There's no way that this could be a negative and cancel this positive 1 out. And that'd be another way to look at it. Okay, I'm going to do as many as I can here. A is f plus g of x. So we need to add our f of x and our g of x. So f of x, A, is going to be 3x plus 4 plus 2x minus 3. Combine our like terms, I end up with 5x plus 1. Domain on that, all real numbers. B, subtracting them, we're going to have 3x plus 4 minus 2x minus 3. So we need to distribute that negative. This is going to be 3x plus 4 minus 2x plus 3, because this negative times a negative is going to be a positive. Combine like terms, I end up with 5x plus 7. C, multiply them. If I multiply them, I'm going to have 3x plus 4 times 2x minus 3. I'm going to distribute and multiply, so 6x squared, 2x times 3x, and then 3x times a minus 3, so minus 9x, 4 times 2 plus 8x, 4 times negative 3, negative 12. Continue to combine like terms. I get 6x squared minus 1x, or you could have just wrote x, minus 12. And again, all real numbers in your domain there. D, we're going to divide f of x divided by, so D, we have 3x plus 4 divided by 2x minus 3. Now notice I'm going to need to have a domain on this one because I have a denominator. So I'd set my denominator equal to 0. So 2x minus 3 equals 0. X equals 3 halves on that one. Okay. Hopefully you can figure that one out. And then we can't do anything else here. So this is our answer. Okay. The reason we can't do anything else is because this up here has nothing in common. The 3x plus 4, they have no common factor. And the bottom, this 2x minus 3 has no common factor either. So therefore, we can't factor anything out and simplify it in any way. All right. E. Okay. What we're doing is we're going to add these together. And once we've added them together, where we see x, we're going to substitute in 3. The nice thing is we've already added these together, so we just have to substitute that 3 in for x. So E is going to piggyback off of A. So where I see x after I've added these together, so I've added these together, I added them together here, and I ended up with 5x plus 1. Everywhere I see x, I need to replace x with 3. So 5 times 3 plus 1 equals 16. Okay. F is going to piggyback off of B. I've already subtracted them. Okay. And once I've subtracted them, which was this, that was my final answer when I subtracted them, where I see x, I'm going to replace it with 4. So 5 times 4 plus 7 equals 27. Okay. Oh, that's because this is not 5x. You probably caught that earlier. Sorry about that. That should just be x plus 7. The 3x minus 2x. Not bad. Therefore, it would be 4 plus 7 equals 11. Whoops. Sorry about that. All right, G. Where you see x, you need to substitute in 2. So I'm going to just give you the answer since my time's running out. You should get 10 on G, and on H, you should get negative 7. Everywhere in here, you're going to replace it with 1.